Hello students, welcome back to my ninth lecture on basic maths. We are doing second chapter, that is sets, relations and functions. In that, in our previous class we dealt with the Venn diagrams, that is a diagrammatic representation of sets, and properties of sets is called as Venn diagram. And also we dealt with the Venn diagram representation like universal set, A union B, A intersection B, A minus B, B minus C, symmetric difference, subset A dash and disjoint sets. In today's session, we are doing some list of formulae based on Venn diagrams, and also we are doing some examples based on this formulae. So let's get started. The list of formulae is: if A and B are two finite sets, then n here is the cardinal number of A union B is written as n of A plus n of B minus n of A intersection B. Here, if there is no common terms between A and B, then we say that n of A intersection B is equals to 0. Then the formula becomes n of A union B is equals to n of A plus n of B. Similarly, we can write if the sets are 3 finite sets, that is A, B and C. Then we will write the same formula like n of A union B union C is equals to n of A plus n of B plus n of C plus n of A intersection B intersection C minus n of A intersection B minus n of B intersection C minus n of A intersection C. Third one, if A and A dash both are finite sets, then n of A dash is written as n of U minus n of A, where U is nothing but universal set. Fourth one, if A and B are two finite sets, then n of A minus B is written as n of A is equals to n of A minus n of A intersection B. Similarly, for n of B minus A is equals to n of B minus n of A intersection B. We are doing examples now. Out of 50 people, 20 people drink tea, 10 take both tea and coffee. How many take at least one of the two drinks? Students, here number of people are 50, that is U is equals to 50. So here in the diagrammatic representation, there are two beverages. One is tea, one circle represents tea and one more is coffee. Here in between tea and coffee, some people are taking both tea and coffee, they are 10. So write 10 in between the two circles, that is common both tea as well as coffee. Now write down the formula. N of T union C is equals to n of T plus n of C minus n of T intersection C. Now substitute their values and simplify. You get n of C is equals to 40. Means 40 people will take at least one of the two drinks. So that is, in the Venn diagram, you just observe, I have written 20, that is 20 people drink tea. In that, subtract 10. Why? Because here 10 are the people, they will take both. If you subtract 10 from 20, you get 10 only. That is the number of people who will take only tea. Similarly, in the circle C, if you subtract 40 minus 10, here 40 how it come? That is n of c is equals to 40. Just now we have calculated. In that subtract 10 only. That 10 is nothing but the common number people who drink both tea as well as coffee. That you have to subtract from 40. You get 30 now. To verify whether it is correct or no, you just add 10, 10 and 30. You get 40 plus 10 people who will take both. That will be equals to 50. Therefore, the number of people who will take at least one of the two drinks is written as 10 plus 10 plus 30. That is nothing but 40 plus 10. 50. Fine. Next question. In a group of 65 people, 40 like cricket, 10 like hockey and cricket both. How many like cricket and cricket only and not hockey? How many like hockey? So read the question carefully, students, and write down the notations. Here the number of people is denoted by U, which is equals to 65. And in a Venn diagram, first circle represents the number of people who play cricket, and second circle represents the number of people who play hockey. Now in between that, I have written 10 over there. That number indicates the number of people they play both the games, hockey as well as cricket. It is represented like n of c intersection h. Now write the formula. N of c union h is equals to n of c plus n of h minus n of c intersection h. Substitute the values. Then you get n of h is equals to 35. That means the number of people who play only hockey is equals to 35. Next example. In a class of 50 students, 15 do not participate in any games. 25 play cricket and 20 play football. Find the number of students who play both. Here given data n of u is equals to 50. Number of students who do not play any games is equals to 15. So now if some students are not playing, then the number of students who are playing will be 50 minus 15, that is 35. That means 35 students are playing any one games. Now n of c is equals to number of students who are playing cricket is equals to 25. Number of students who are playing football is equals to 20. And number of students who play both the games is your question. That is, so write down the formula. N of C union F is equals to N of C plus N of F minus N of C intersection F. Substitute the formula. You get the number of students who play both the games is equals to 10. In Venn diagram, you represent the values. U is equals to 50. First circle indicates the number of students who play cricket. Second circle represents the number of students who play football. The number of students who play both the games is equals to 10. Represent exactly in the middle of the circle. Then in 25 subtract the common number, that is minus 10. You get 15. Similarly, here in 20, if you subtract 10, the common people, you have to subtract from 20, you get 10 only. Therefore, the number of students who play both the games are 10. To verify whether we have done correct or no, you just add 15, 10 and 10. That is equals to 35. 35 students are playing the games out of 50 and remaining 15 students are not participating in any games. Next question. These questions are from exercise. In a class of 100 students, 35 play football, 45 play basketball, 35 play indoor games, 10 play football and basketball, 15 play basketball and indoor games, 5 play football, basketball and indoor games. If 15 do not play any games, then find how many play football and indoor games. Students, this question contains 3 different stages. That is, one stage contains the number of students who are playing football, and second stage contains the number of students who play basketball, and third stage contains the number of students who are playing indoor games. Now, some students are playing both the games, football as well as basketball, basketball as well as indoor games as well as football. Okay, some students are playing all the 3 games. So, write down all the data first. Okay, that is, here number of students, n of u is equals to 100 and n of f, that is number of students who are playing football, is equals to 35, n of basketball is equals to 45, number of students who are playing indoor games is equals to 35, and the students who are playing football as well as basketball is denoted by the symbol n of f intersection bb is equals to 10, and the number of students who are playing basketball and indoor games is equals to 15, and number of students who are playing basketball, football and indoor games is equals to 5. Write down all the data first, then represent these data in the circles, Venn diagram. Then number of students who do not play is also given, that is 15. Out of 100, subtract 15 students, those who are not playing, then we get the number of students who are playing, that is equals to 85. 100 minus 15 is 85. Now, here you just observe the first circle, that is F and B and I. In the first circle, I have written 35 minus 10 minus x. Why 10? See, n of f is equals to 35 minus common you have to remove. Here exactly in the middle of all the 3 circles I have written 5. That 5 is nothing but the students who are playing all the 3 games. Okay, that 5, and in between F and B there I have written 5. Add them. 5 plus 5 is 10 minus x. Number of students who are playing F and football and indoor games is your question. So take here as the unknown term, that is x. Now 35 minus 10 minus x is equals to 25 minus x. So keep it in the circle itself. Second circle, the common numbers you have to subtract from 45. That is, in basketball circle I am explaining. That is 45 minus 5 plus 5 is 10. 10 plus 10 is 20. You get 25. Okay. Then in the third circle, that is indoor games. The indoor games players are 35. In 35, the number of students who are playing all the 3 games and the 2 games, common games, that is B and I, is written here as 10. 10 plus 5 is 15. 15 minus x. You have to subtract from how much? 35. Then you get 20 minus x. Okay, you observe it carefully and draw. Then you will understand better. Now, come to the calculation part. Total students who play we get only after adding the numbers which are in the F, B and I circle. Also we have to take the numbers which are in between the common circles. That is, add the numbers 25 minus x plus 5 plus 25 plus 10 plus 5 plus x plus 25 minus x. If you do so, then here x and x will get cancelled. Then simplify the RHS part and equate it to 85. 85 is nothing but the total number of students who play. Then you get the value of x is equals to 5. That means the value of x is here is equal to 5 means the students who are playing both football and indoor games is equals to 10. Why I have written 10 here means this 5 I have added. X is equals to 10. 10 we get by adding 5 to 5. Next question. In a class of 150 students, it was found that 95 like burgers and 79 like pizzas. Assuming every student like at least one of the above, find the number of students who like both burgers and pizzas. Show the result through Venn diagram. So students, I have left Venn diagram for you. Only calculation part I am doing here. I hope you will do this. Here n of u is equals to n of b union p, that is b for burger, p for pizza. That is equals to 150. And number of students who like burger is equals to 95. And number of students who like pizza is equals to 79. Now, n of b intersection p is equals to question mark. That is number of students who like both burger and pizza is equals to question mark. Now substitute the formula. In the formula you get n of b intersection p is equals to 24. Represent the same data in Venn diagram. With this I will conclude. With more examples I will meet you in the next session. Thank you.